So, hi guys, my name is Diogo Junior. I've been working on Android since 2008 as an Android developer. At that time, nobody, not that level of people would have already knew about Android. Neither developers, neither customers, let's say. So Android only started then, later in 2010. 11, 12, the big boom. But at that time, there was not even hardware, so it was necessary to do the applications only with the emulator. But then I've also continued working on development of Android applications in Fraunhofer Portugal Institute, then more in the industry side, in working for Jumia with an e-commerce application. Then in this company, Sete Graus, I've developed one of the most important applications in my professional career, let's say, that with a lot of users, a lot of users that benefit from this application. It was basically a dictionary for Brazilian people. That was very interesting. And then I started working in 2018 for CTW. We work with, we are a BMW company as an Android engineer, let's say. So in case you have questions, please go ahead. But otherwise, I can continue because I have a lot of information, and I will try here to give you an overview about what I will talk about during this roughly 20 minutes. So basically, I will give you an overview about the connectivity inside Android, the implications, the dependencies, and the architecture, and then I will also talk about a little bit about the radio interface layer and what's that inside the Android. So basically here, just to give you a big overview about the components involved in connectivity. This is an old diagram, an old draw that I got from the internet, but some of the ways of communicating between these components are not that anymore. They are not anymore using sockets, but using binder and headers. But the components are the same. So basically, we have the framework where we have the connectivity service, the network manager, etc. And then we have the netd component, and then we have the kernel that, as usual, as always. We will be basic. I will give you basically the overview and the responsibilities of the netd binary, and also the framework and the APIs and the responsibilities, etc. And the kernel, there is not that much differences. So it's just about the modules, the components, the drivers, or the specific, depending on the hardware that is being used. But yeah, so continuing, basically regarding the connectivity API on Android, these are the mainly responsibilities of the connectivity API. So basically, the idea is that it monitors the connections independently of the transport type, being Wi-Fi, mobile, Ethernet, etc. And then it sends also the broadcast to the applications in case applications want to know if there is connectivity or not, if it lost connection through cellular transport type, etc. Then it also tries to optimize and optimize the number of connections that are alive. So because this started as a operating system for smartphones, and in 2010 the battery had only 200 or 300 milliamperes per hour, so the poor capacity. So the resource usages was quite important. So this still it's not that a level anymore. It's not so aggressive. It's not so problematic, but there are some workarounds as we will see, but it continues to optimize the number of connections active at the same time. And it tries to fail over in case a connection disappears, as we will see in a moment. And then it also gives some possibility for applications for developers in order to check if this connection is available or not, scanning Wi-Fi SSIDs, etc., and then start and stop using that specific application network for the application. Here we can see an example of the API that the applications can use through the connectivity manager. Basically, we can simply create this network request using this builder pattern. And then we here specify that we want to register a network callback for this for a network that has this transport cellular. And then as soon as the network is available, or in case the connection is lost, we will receive the trigger on our application. But there are other API methods that applications can use in order to have the functionalities that I described in the previous slide. So then now regarding the NetD, this component that we can see here, and what are their responsibilities. Basically, the NetD daemon, it's better to see this graphic here while I am describing the functionality. Basically, the NetD daemon is responsible for receiving and also passing some events from down to up layer, but mainly by receiving the components from the framework, being setting IP addresses for the interfaces, the gateways, the DNS, etc. All those information that is managed by the framework is then passed through the NetD binary process that then communicates directly with the kernel, with the operating system. Okay. So basically here in the NetD daemon, we can see here the run command that starts the binary process that is located in the system bin NetD. We can see here what's the location inside the AOSP source. It has some the class main and the sockets that are being used, the on restart flags, etc. And then here we can see the source, the main entry point of the main.cpp of the NetD command. There is nothing important here in the source code, just then it uses an idle interface between the framework and the NetD that in order to communicate through the binder between the framework and the binary process NetD. There is also this NDC command that it's also a binary that is available in the instances. Sorry. And basically, with this binary, we can communicate directly with the NetD, which means that it's not necessary to be the framework communicating with the NetD. We can use this NDC utility that is available in the instance, and then you can also pass some comments through the NetD in order to, for example, to test your system in case you want to create a new connection to specify a specific IP address for a specific interface. You can use this. There are these multiple commands. I basically just also use this screenshot in order to show what are the type of comments that the framework can pass to NetD, and then the NetD are responsible for setting all those parameters within your system. So basically here we have this interface command that basically receives some commands for the interface, like the IP addresses, DNSs, MTUs, etc. Then this is the IP forward command for the specific interface in case you want to enable the forward thing. The tethering, the NAT, network address translation commands, bandwidth control, idle timers for those, firewall IP tables, rules, etc., CLAP networks, etc. So multiple commands that can be specified, not yet by the framework, but also using this NDC command in case you want to perform some tests. So this was about this intermediate layer, the NetD. And then we have, of course, the framework layer that passes all the necessary comments to the netd and then to the system. But the idea is that the connectivity service also has some sorry, some responsibility. So basically, it has all the responsibilities that I told you about in the first slide, and then it tries basically to optimize the number of active networks in the system. In the latest versions of Android, 12 and 13, it was not so aggressive. Let's say there are some flags that can be set in order to maintain multiple networks available at the same time. But the basic functionality by default, it disables all the not necessary connections, because basically the thing is that how it works, basically, the connectivity service. In the beginning, it creates some network requests, some basic network requests with some capabilities that we will see in a moment. And then it checks what are the interfaces that fulfill those requests. So, and in case there is a network, for example, a cellular network or a Wi-Fi network, in case in your system you have cellular and a Wi-Fi network at the same time, in case you have a Wi-Fi network with with a better score, let's say, then you don't need to have the cellular network, which means that the cellular network can be disabled and shut down. So in order to do this, it attributes some score mechanisms to the different networks, not just about the transport type that you can see here in the slide. What's the score? Which means that the highest score means better connection, which means that the others are not considered and are disconnected, and basically they are not considered to be the default network. Connectivity service, as always, a default network, and that is the one that, in case, for example, the applications only open a socket and want to consume an HTTP API or something like that, it will basically use that connection in case the application is not asking for a specific connection with a specific transport type or with a specific capability. Yeah, I will show you the capabilities in a moment. We will understand better these capabilities and transport types as soon as I talk about a little bit about the Ethernet thing. So on Android, on Automotive, basically there are some differences between the smartphones and the Automotive scenarios, let's say. So basically, usually in Automotive, the modem isn't in the same SoC as we have in our smartphone. So which means that usually there is this switch in the middle that allows you to use the modem capabilities. And that involves some workarounds that need to be implemented, because basically the modem is not in the same ECU, so you can't implement the radio and the kernel and the modules are not in that SoC. So basically in 2016, this slide is from the bootcamp from Google bootcamp, and basically they presented these two possibilities for Automotive OEMs. Basically, there are these two different approaches in order to implement these different radio these connections. So there are these options here, as phones do today, because the modem is available in the same SoC, or this other option here, which Wi-Fi and radio are not implemented. So I will not talk about Wi-Fi, but I will talk about radio where the modem is available. So because it's not possible to have an Ethernet cable connected to each Automotive. So that's why the modem is quite important in this scenario. So I will talk about these two possibilities, implementing these two possibilities. This one is the easiest one, so I will talk right now. So basically here, instead of having this radio connection, let's say the cellular connection available through the framework, which means that applications can, for example, in case you install an application that requests explicitly to use the cellular network, that network won't ever be available. So that application won't work out of the box. Will need to be readapted or something like that. But in case the application requests that specific type of network, that network won't be available. But it will be available, for example, through Ethernet. That's basically the workaround. As we saw here, we will have a switch, and then basically that network that is going to be actually a cellular network available in another ECU, it will be available as an Ethernet connection. And that's why Google implemented this Ethernet tracker. We will see that in a moment. This Ethernet tracker here that basically allows you to get these resources values that are defined here in these config Ethernet interfaces that can be specified here in these frameworks based core res config XML file, where we can specify all the parameters for the specific connections interfaces. In this case, we have ETH01 and 02. We can define the IP address, the mask, the gateway, the DNS that can be used for specific interfaces. And then we have also these important things here that are the capabilities. The capabilities, as you can see here, basically we can specify if this network is metered or not metered. If in case we don't specify this 11 capability, it means that it is metered. If it has internet, if it is not restricted, and then we also have these new extra flags that have been added in the latest Android versions, this OEM private thing that works with the PANs for the per application network selection. That was something that was requested by automotive OEMs, because basically there are some connections that they pay the traffic, and then they don't want other applications to be using that network. So there is a central component that specifies per package name. Okay, you use this network, you will use another network. And then basically the networks that have this 26 capability cannot be used by the connectivity service, does not select it as the default network connection. And then only specific applications can use this network, which means that is, for example, this use case, this ETH01 is the one that will be used just by specific applications. And then we have also here this 27, that means that it is a vehicle internal network. And then in case we specify here these workarounds here, that again, connectivity service allows you to, this is basically the workarounds that I was talking about before. That means that in case we specify these values as true, this mobile data always on, we can basically control the behavior of the connectivity service in order to do not turn off the mobile data connection, even even if there is a better network connection, which means that, for example, in case you are using Wi-Fi, but as soon as you get Wi-Fi connection lost, in case the cellular connection have been dropped, so then you need to set up the connection, etc., etc. That takes time. So the idea is that you can remain the mobile connection remains active, and as soon as you get lost Wi-Fi connection, you automatically your application doesn't even notice that you are already using another type of connection. And then
Diogo, you have 4 minutes left.
Oops, only. Okay, sorry. So I need to hurry up. So yeah, basically this is how you can control these parameters. Coming a little bit back, so then you can also override here the transport type, as these are actually not Ethernet connections, because they might be cellular connections, and in this case we have here Bluetooth. But the idea here is that you can control in your system what's going to be also the default network connection, because basically with this transport type it has a Haga score, let's say. So continue. Well, in case you want to debug all these connectivity details, there are multiple services that are running in the system server process that gives you a lot of information about what's the status. And in case you are working with connectivity, you are constantly using these DAMSys NetP connectivity, Ethernet, tethering, etc., in order to check what's the status. And basically, it executes the dump from these multiple services. Here we can see a basic example where you can see what are the default network ID and the multiple information about the score, what's the IPs, what's the capabilities, the requests, and the applications that are being fulfilled by this network, etc. So, and then you have the other option that is by actually implementing the radio interface layer. So, in this radio interface layer, again, showing a diagram so that we can also visualize and have a better understanding of the component that we are talking about. Basically, here we have the phone application, where is all this logic, the call data tracker, the data tracker, service tracker, etc., SMS, blah, blah, blah. And then we have also in the framework this central component here that is the real J, that basically talks with the underdoed component that is the real daemon here, and then the real implementation is actually in this shared library, this vendor real vendor shared library, where then depending on the modem, OEM, then the OEM, the vendor implements here the communication with that specific modem. Here we can see the real daemon. Basically, the daemon loads the shared library. The shared library is available through a system property under this property here, this lib path. It is somewhere in the system, and basically there are some contract between the real daemon and also this shared library, a function that needs to be registered, and then it gives some it gives the opportunity to the shared library, to the modem to implement the requested functions that we'll see in a moment. So basically, here we can see what is the source files that are available through this hardware lib_real, and in this real service, it basically registers the service that then through the HIDL, it will communicate between the framework and the real daemon. In the real comments and the real unsolicited comments, there are the comments that are basically the interface between the framework and the real, and that need to be fulfilled even from both sides, which means that there are
you have 1 minute left, so if you could just bring it to a conclusion, that'd be just great.
Okay, I will try. There are still some slides, but I will talk faster. So basically, there are some solicited comments that are passed between the framework and the real, and then there are also some unsolicited comments that are the ones that happens in case there is a new SMS or the network changes, etc. So here is how you can implement the lib_real, some configuration files that need to be adapted in case you don't have SMS or voice or etc. Here is the path. And then this is basically the life cycle of the framework. So basically the framework starts the telephony application, then it starts getting some comments to your real. These are get hardware configuration, radio pair, etc. baseband version. And then as soon as we get this get IMSI, it will give you the international mobile subscriber identification. It gives you the mobile network country code, etc. And then the telephony application gets these APN connections from the multiple networks over the world, and from the one that the modem gets you to the framework, it will then perform this real request set initial attach APN, and then gives you all the details, and then the setup data call gives you back from the real C, from the lib_real to the real J to the framework, real J to the framework, the details, the DNS address, and then we happens again what I described before. And as in case you want to debug all this information, it's good to check all these properties that I mentioned before with this get prop and getting by real, and then you need also to analyze the logs that are in a different buffer that is in the radio buffer. All the logs related to telephony are in this radio buffer. You can grab by real C and real G in order to get the communication, what real J is communicating and the real C responding back. And then you can also, from the up level side, let's say, use this activity here that gives you all the details and information about the telephony status. And that's it. Sorry for hurrying out in the end, but yeah, it's a lot of information.
No, that's fantastic. Thank you.